Ever reach for your car keys on the hook by the door,
Hmm.
only to find, the hook completely empty?
Oh, yeah, that feeling.
Or maybe tried to use a tool that just wasn't put together yet, you're left kind of scratching your head?
Uh-huh.
It's that moment of, wait, this isn't actually here.
Hmm.
Well, in the world of Java programming, there's a very common, often frustrating, yet incredibly important concept that acts exactly like this. It's called the null pointer exception.
Right.
And what's wild is that the very idea of null, its inventor, actually called it his billion-dollar mistake.
It's true. And it's fascinating, isn't it, how universal that feeling is? Something missing, an expectation not met. It translates so directly into code.
Absolutely. So today we're diving deep into Java's null pointer exception, or NPE for short.
Yep.
For anyone navigating the world of Java, whether you're just starting out or, you're a seasoned pro, it's probably one of the most frequent gotchas you'll hit.
Oh, for sure.
Our mission today is really to demystify the NPE for you, the listener. We want to turn what's often a source of bugs into more of an aha moment.
Yeah, understand why it bites you.
Exactly. We'll unpack what it is, why it happens, how it actually works under the hood, the problems it causes, maybe some hidden advantages, and, crucially, what you can do to handle it like a pro.
Hopefully save yourself some of those future headaches, maybe some costly bugs too.
Let's hope so.
Hmm.
So let's start right at the core definition. What is a null pointer exception?
Okay, so a null pointer exception is what's called a runtime exception in Java. It happens when your program tries to use a reference variable that is null.
And null just means nothing, no object.
Exactly. It means that variable isn't pointing to any actual object in memory. But your code tries to use it anyway in a way that needs an object, like maybe calling a method on it or trying to access one of its fields.
Right. I like the analogy we found for this. Think of an NPE like an error you get when you try to open an empty box, but you're expecting something specific inside. If the box that's your null reference contains nothing, Java basically throws up its hands and gives you an NPE. It's an alert saying, hey, I can't do that. There's nothing here.
Precisely. And that connects right back to why it occurs, fundamentally. It's because variables that are supposed to point to objects can be null. They're allowed to be in this state of like an empty placeholder.
Okay, so it's like a variable that says, I intend to hold an object, but it hasn't actually been given one yet.
Yeah, exactly. It's declared its intention, but nothing's assigned.
So null itself isn't inherently bad then. It's the trying to use it as if it were something. That's the problem.
You got it. That's the crux of it.
Okay, that makes sense.
Yeah.
So where do developers most often, trip over this empty box problem in their code? What are the classic pitfalls?
That's a great question because they pop up in really common spots. One big one is when a method returns null. Maybe it couldn't find something or an error happened.
Right.
And the code that called the method, it just doesn't check. It assumes it got a real object back and tries to use it. Boom. NPE. Ah, okay. What else?
Another super common one is simply declaring an object variable, but then forgetting to initialize it before you use it.
Like, you write string myString, but then immediately try myString.length.
Exactly that. You've set up the placeholder myString, but you never assigned an actual string object to it, like myString hello. So it's still null.
Gotcha. Any other main scenarios?
Yeah. One more big category is working with collections or arrays. You might have a list or a map or an array, and one of the elements inside it is null. And then your code loops through, pulls out that null element, and tries to treat it like a valid object. Same result. NPE.
So these are all just flavors of trying to use that empty box.
Pretty much, yeah. Different ways to stumble into the same problem.
It sounds like Java isn't trying to be difficult with these NPEs then. It feels more like it's sending a signal.
Definitely not trying to be difficult. You wouldn't intentionally use an NPE as part of your program's logic. They are Java's way of signaling that something invalid happened with a null reference.
A safety net. Exactly, a crucial safety mechanism. It prevents really unpredictable behavior, maybe data corruption, and it helps you, the developer, find where your assumptions about the data were wrong. It's Java saying, hold on, you assumed something was here, but it isn't. If I let you continue, things could get really weird.
Okay, so it's like Java's giving us a bit of tough love. But beyond just that warning, what's the real value for our listeners in getting a handle on this specific exception? Why should they really care about understanding NPs?
That's a really good point because it's not just about avoiding crashes. It's about building better, more robust software.
How so?
Well, first, they're fantastic for error detection. An NPE instantly points to a logical flaw. Maybe you forgot a null check, maybe your data source isn't providing what you thought.
Okay.
Second, they are surprisingly good debugging aids. When an NPE happens, you get that stack trace.
Right, the wall of text.
Yeah, sometimes. But it pinpoints the exact line of code where the error occurred. It's like a map showing you exactly where the problem is, not just a vague something went wrong message.
Yeah. So it's not just a generic error. It's like a laser pointer saying, look here. That's a huge help when you're staring at, tons of code.
It really is. And you need that help because they are incredibly prevalent. You'll see NPEs constantly when dealing with things like uninitialized objects, handling optional data, maybe from a database where a column might be empty, or from an API.
On user input that might be missed.
Exactly. User input is a classic one. So for beginners especially, understanding NPEs is just fundamental. It's one of the most common bugs they'll hit. Learning to handle null correctly is a huge step towards writing reliable, professional-level Java code.
Master this, and you're already way ahead.
Definitely.
Okay, so we know what it is, why it matters. But let's peel back the onion a bit more. How does Java actually do this? Like, inside the machine. How does the JVM know to throw this specific exception when all it sees is a reference pointing to nothing?
Yeah, this gets interesting. It involves a runtime check happening constantly as your code runs. When your Java code tries to dereference a null value, that fancy term just means trying to follow the reference to do something, like call a method or access a field.
Like trying to open that empty box.
Exactly. The Java virtual machine, the JVM, sees this attempt. It knows that this particular reference doesn't point to any valid object. Internally, null is often represented by a special memory address that's invalid for objects, typically address 0.
Address 0. So it's like trying to access memory location number 0. That sounds restricted.
It absolutely is. It's usually protected by the operating system. So when your program tries to access memory using that null reference address 0, the underlying operating system actually catches it first. It sees an attempt to access memory it shouldn't, and it generates a low-level fault. You might hear terms like segmentation fault or access violation in other contexts.
Oh, okay.
The JVM is smart enough to intercept that low-level OS fault. It recognizes it came from trying to use a null reference in the Java code, and it translates that system-level error into our nice Java-specific null pointer exception.
Wow. So it's quite a chain reaction from the code to the JVM to the OS and back to the JVM throwing the exception.
It is. The JVM essentially catches the low-level problem and says, I know what this is in Java terms. You tried to use null. Here's an NPE. And then it creates that null pointer exception object, complete with the helpful stack trace we talked about.
And you mentioned it's a runtime exception. That's why we don't have to catch it everywhere.
Precisely. It's unchecked, which means you don't need to declare throws null pointer exception in your method signatures or wrap every single object access in a try-catch block.
Which sounds convenient.
It is convenient. It avoids a lot of code clutter, but it's also why they can sneak up on you so easily during development. You're not forced to think about them at compile time.
Okay, so the system's always watching for that step into the forbidden zone at runtime and bang, NPE.
You got it. And that stack trace is still your map, but now you maybe understand a bit more about why that map gets generated.
Right, so it seems like the NPE has this dual nature. It causes a lot of problems, but it also has these maybe surprising advantages. Let's talk about the problems first.
Yeah.
What are the common headaches? I mean, every Java dev has an NPE war story.
Oh,
right?
absolutely. Mine usually involve chasing something late on a Friday.
Same here. A weekend debugging session over one tiny missing config value once. Does that sound familiar?
Painfully familiar. Yeah, I once spent hours tracing an NPE that turned out to be like a single character typo in a file path or a database column that just hadn't been created yet in the test environment. It's almost a rite of passage.
So what are the main categories of problems?
Well, the most obvious one is just frequent bugs. They're super common, especially for beginners, partly because null is the default for object references if you don't initialize them. Easy to overlook.
Okay, makes sense.
Then there's the debugging difficulty we touched on. Even with the stack trace, sometimes the null value itself might have been passed around through several different methods before it finally gets used improperly and triggers the NPE.
So the place where it blows up isn't necessarily where the null originated.
Exactly. The root cause might be way earlier in the call chain, so you end up having to trace it back, which can be a real pain in complex systems. A frustrating treasure hunt, like you said.
Yeah. What else?
This often leads to code clutter. To try and prevent NPEs, developers sprinkle if X null checks everywhere.
Guilty as charged.
We all are. But while those checks are often necessary, too many of them can make the code really verbose, harder to read, and kind of obscure the main logic you're trying to implement.
Right, the important stuff gets lost in the null checks.
Yeah. And then there are just unexpected nulls. You call a method, maybe from a third-party library or an API, and you assume it will always return a value. But maybe it returns null if there's no data, or if there was a network blip, or maybe the documentation wasn't clear. If your code isn't prepared for that null, bam.
And I bet if different parts of a big project handle null inconsistently, that's a maintenance nightmare waiting to happen.
Oh, absolutely. It creates hidden landmines for anyone new coming onto the project, or even for yourself 6 months later.
Okay, so those are the downsides. But you said there are advantages too, besides just stopping the program from doing something weird.
Yes, definitely. We touched on some, but let's recap. First, that error detection is huge. NPEs stop invalid operations immediately. They prevent your program from continuing in an undefined state, which could lead to silent data corruption or really bizarre, hard-to-diagnose crashes later on.
So better a clear crash now than subtle weirdness later.
Much better, usually. Second, that clear feedback. The stack trace, as we keep saying, points right to the line. That's invaluable compared to some generic error messages you might get.
Okay, and the third advantage. You mentioned it pushes developers towards better practices.
Yes, I think this is a really important one. Constantly running into NPEs, or the fear of them, actively encourages developers to adopt safer ways to handle potentially missing values.
Like using optional.
Exactly like using optional. Java 8 introduced the optional class specifically for this. It's a container object that may or may not contain a non-null value. Using it makes it explicit in your code that a value might be absent.
So it forces you to think about the missing case.
It does. It reduces the need for all those scattered if-X null checks and makes the code's intent much clearer. It really improves overall code quality by making you confront the possibility of absence up front.
Okay, that makes a lot of sense.
Yeah.
So we've covered the what, why, how, the good and the bad, but let's bring it home for you, the listener. How can you go from being enamored by NPEs to actually mastering them and writing code that's, well, more resilient? What are the practical steps?
Right. This is the key takeaway. First, and maybe most importantly, understand null. Accept that it's a valid state for reference variables in Java. It's not inherently an error, it just means no objects.
So don't fear the null, respect the null.
Kind of, yeah. And because it's a valid state, you have to always consider, could this reference be null right now before you try to use it?
Which leads to checking for it.
Exactly. Point 2, get in the habit of checking for null before you call methods or access fields on an object reference, especially for anything returned from a method you didn't write, or pulled from a collection, or read from a database or API. Those are prime candidates for being null unexpectedly.
And this is where optional comes in again, right? To make those checks cleaner.
Precisely. Point 3, if you're using Java 8 or later, seriously explore optional. It's designed for this exact problem. It lets you handle potentially absent values much more elegantly and safely than manual null checks. You can chain operations, provide defaults. It's powerful.
Okay, what's next?
Next, when an NPE does happen, because let's be real, they still will sometimes, learn to love the stack trace. Read it from the top down. The first line that points to code you wrote, that's usually where the problem is. It's your debug roadmap. Don't ignore it.
So don't just glance at it and panic.
Read it. Read it. It's telling you something important. Also, simple but crucial, initialize your variables. Make sure your object references actually point to an object before you use them. Either assign a sensible default value or create a new object right away. Don't leave them null by accident.
Good practice hygiene, basically.
Yep. And be cautious with methods that might return null. Check the documentation. If a method says it can return null, like map.getKey does if the key isn't found, believe it and handle that possibility in your calling code. If the docs are vague, maybe write a small test to see what it does.
So it boils down to adopting a kind of defensive programming mindset.
Exactly that. What are we on? 7. Adopt defensive programming. Write your code assuming things might go wrong. Assume input might be missing. Assume external services might fail. Assume data might be null. Build in checks and safeguards. Anticipate problems.
Assume the worst, hope for the best.
Sort of, yeah. And related to that, test thoroughly. Don't just test the happy path. Test the edge cases. What happens with empty input? What happens if that optional database field is missing? Try to trigger those NPEs in your tests so you can fix them before they hit users.
Find them before they find you.
You got it. And finally, learn from others. Look at how modern Java frameworks like Spring or libraries like Google's Guava handle nullability. They often use annotations, at non-null, at nullable, or lean heavily on optional to make things safer. See how the pros do it.
Great tips. Okay, so let's try and wrap this deep dive up.
Yeah.
The null pointer exception. It's a runtime error in Java,
Yeah.
but it's not just a random annoyance.
Not at all.
It's actually a key safety mechanism.
Yeah.
It highlights mistakes in your code when you try to use a null reference like it's a real object.
Stops you from doing something potentially dangerous or nonsensical.
Right. And while, yeah, it's a super common source of bugs and debugging headaches, if you understand it, it gives you those clear stack traces and, maybe more importantly, it pushes you towards writing code that's more robust, more reliable, more thoughtful, really.
It forces you to be explicit about your data, about what might be there and what might not. Precision.
It does.
Yeah.
And so, for you, the listener, maybe the challenge is to shift how you see null. Don't see it as this scary monster hiding in the shadows of your code.
See it as a signal.
Yeah, exactly.
Yeah.
Signal. An opportunity, even. An opportunity to write better, more resilient code. And maybe think about how those principles we talked about, anticipating the unexpected, checking your assumptions, building in safeguards, how those apply beyond just Java.
That's interesting.
How could they apply to crafting any reliable system? Or even just how you approach problems in everyday life.
That idea of defensive thinking, how could that improve things outside of programming? It's a powerful concept, definitely. Thinking about resilience, whether it's code or, I don't know, planning a project or even communicating with people.
Absolutely. Something to chew on. So keep exploring, keep applying what you've learned today, and keep diving deep into how things really work.